manage. So, and after this diode circuits, we'll discuss the application of diodes. Like first is rectifier, next again Zener regulator, like this it will come. I'll start with the diode circuits. Now, when a diode is said to be forward biased or when it is said to be reverse biased, suppose if a diode is there, I'll show PN like this. So let this be bias potential or potential barrier. It's a silicon diode, 0.7 volt. No? I'll apply 1 volt. I'll apply 0.3 volt here. Is it forward bias or reverse bias? What do you mean by forward bias? If P is more positive than N by 0.7, it's said to be forward bias. Now, what is this diode? Is it forward bias or reverse bias? So I can say it is a forward bias. Let me copy this because I'll give several cases. Okay. No. So shall I say this is a forward bias or reverse bias? Definitely the answer will be it is a forward bias because P is more positive than N by 0.2. Or in another one, what about this? N is minus 0.4, P is 0.3 volt. Forward bias or reverse bias. In either way, if N is more negative than P by 0.7, then it's said to be forward bias. So this diode is what? Forward biased here. N is minus 0.7, P is 0 volt. So it will be forward biased. Now look at this second case. P should be more positive than N by 0.7. So how much it is? The difference of voltage is 0.1 volt only. So you don't call reverse bias unbiased. I think there's a difference there. Reverse bias, unbiased here. It's unbiased here. So P is more positive than N by how much? Not 0.7, but 0.1 volt. So it's unbiased. Will there be any small current? S, very small current will flow here. Or better say we off according to our conditions, better when it will start conducting, when it is forward bias is what we use in application. You go back to the PV diagram, in which region the diode will be used. The diode will be used in this region, not here. Anywhere, even you should not call this a forward bias. This is the forward bias, where the applied voltage is greater than the knee voltage. This is the forward bias region. So here also forward bias, but we cannot use this in applications of no use. Getting the idea? This I think we called knee voltage, no? Now come for this one. Mm. 1 volt and 0.3 volt. It must be reverse bias, no? Because N is more negative than P by how much? 0.7. So it is a reverse biased. Say for reverse bias, nothing is there. For reverse bias, what happens? Anything non-zero voltage. Now, N is more negative than P. N is more negative than P. So how much it is? 0.1 minus 0.1. So is it forward bias or reverse bias? You have to call unbiased here.
0.7 only now, sir.
Okay, 0.7. I'll write like this. Unbiased. If I write, already is there, no? Second case is there already. One more, unbiased, everything is order. Yeah. Then this will be forward biased. Okay, this is, I think, very popular. 2 times they've asked like this, simple. They're given 4 diagrams, they're given voltages. They're asking whether forward bias, reverse bias, or unbiased. So they'll give barrier potential. That is very important. It's a silicon diode we took. If the germanium diode, 0.3 will come. Then with respect to 0.3, germanium diode will be forward bias when P is more positive than N by 0.3. So I think this barrier potential also you have to wait for.